Hey guys, what is up? So today we are going to be solving partitioning into minimum number of binary numbers. So let's first understand the problem. So the problem says that a decimal number is called binary if each of its digit is either 0 or 1 without any leading zeros. For example, 101, 1100 are binary. So because these only have 1 1 and 0 0 as the digit, these are binary numbers, while 112 and 3001 are not binary, especially because this doesn't has a 0, and the other thing is it has a number other than 1 and a 0. So we are given a string n that represents a positive decimal integer, okay, like 32 over here, and we need to return the minimum number of positive binary numbers needed so that they sum up to n. So now let's understand it from an example. Say we are given n is equals to 32, which is a string, right? So we need to give binary numbers which would sum up to 32. So the simplest example of it is which are these. So yeah, so these are the binary numbers. Minimum 3 binary numbers are needed to actually sum up to 32. So now let's take a look at some another example. So let's say we want 51. So what should be the binary numbers that would lead to 51? Now let's talk about uh, the highest two-digit binary number. Okay, it's 11, right? And the second highest two-digit binary number is 10. Then we have 10. Then we have 10. Again, we have 10 over here, right? Right, and all of these sum up to 51. So there's one common pattern that I'm seeing over here is, say you're given a number. Let's take a really big number. Let's say you're given 243, and you want to tell what are the minimum number of binary numbers needed to actually form 243. If we add those numbers, you get 243. So the simple reasoning is that uh, for this, for the ones place, you'll actually need three ones over here. For the tens place, you will actually need four ones, and for the hundred place, you'll actually need two ones. So what I actually mean is, just look very closely, right? So let's do it. Let's do one, one, and one. Then let's do one. Again, let's do one and one. This is another number, and now let's shift it to 0, 1, 1, and the other one is 0, 1, and 0. Now let's try and add these numbers. So if you add these numbers, you get 1 plus 1 plus 1, it's 3. And the other time you get 1 plus 1 plus 1 plus 1, it's 4. And the other time you get 243. So these are the four binary numbers, binary numbers which will actually give me 243, right? Uh, so after doing this, you will start noticing a common pattern. Here 4 is the highest number, right? So 4 is the highest number we have. Here 5 was the highest number we have. So the number of binary numbers we used was actually 4, right? And here we used 1, 2, 3, 4, and 5. 5 binary numbers, and the highest was 5, right? Now let's try and verify it once again with some other example. So now let's try and look at some other example. Let's do it with a smaller number, which is easier to verify. So let's do it with say 21. Let's take example 21. What do you think would be the two binary numbers which would give us 21? So it's pretty easy to think. It's it's these. So at the ones place you just need one one, right? And at the tens place you need two ones to actually form 21. What is the highest number over here? It's 21. It's actually 2 in 21 is the highest number, and the number of binary numbers that were needed were actually 2 binary. Now one was 10 and the other one was 11. So one thing is confirm, whatever is the max number in the string would be a decibinary number, right? So now let's start coding the solution. So let's take current maximum as 0, and then we'll iterate through the string. So for I in n, if integer of I is greater than maximum, then maximum would become integer, and if integer I is equals to 9, then greater than integer I, or else just ready maximum. Now let's try and run this. Okay, now let's try and submit this. Yep, it's accepted. So let me just tell you what this line does. This line is there so that the loop doesn't run, uh, so that the whole loop has not to run, right? So for example, say you get a number like something like 798,675, right? So we have already seen that the maximum number of decibinary number is equal to the maximum uh, numeric value you have in your string, and the maximum numeric value that you could have is 9. So if you encounter 9, you just need to return the value. So the how would the loop run? So the loop would run like for 7 in n, if 7 is greater than maximum would become 7, right? So we have a maximum of value 7. Then for 9 in n, so 9 is greater than maximum, which is actually 7, so maximum would become now 9. And if uh, the current iteration is 9, you just have to return that, because that's the maximum. So after this, after just running 0th and first step, the loop would actually stop running and would just return the value.